My dear friends, good morning to you all. I welcome you all to our Sri classroom, and today's our topic is continuation of the functions. In the last two classes, we have discussed some of the features of the functions and how functions can be used in the C programs. In today's class, we are going to see how arrays are passed as argument to the functions and how can we pass strings as arguments to the function, and then we will be discussing some programs, and then we are moving to important questions, and I am also giving some programs to you for practice at your home. You can practice some programs on your computer at your home, so that you will be getting the confidence on functions. Now let us start today's class with how do we pass arrays as argument to the functions. If you see, in the last class we discussed how do we pass variables of primary data type as an argument to the functions. Similarly, we discussed how to pass pointers as argument to the functions. And then in today's class, we will discuss how to pass arrays as an argument to the functions. Arrays, like normal variables, they can also be passed as argument to the functions. And for that, at some places, the called function should be defined properly and it should be declared properly. And how it can be done with the called function, and what are the responsibilities to be fulfilled by the calling function. We are going to see calling function and a called function. Calling function should make a proper call to the called function by passing the arrays appropriately as an argument to the called function. Similarly, called function should be defined properly to receive array as an argument from the calling function. The prototype declaration of called function should also be done properly to inform the compiler that this called function is going to receive an array as an argument from the calling function. Like that, the prototype declaration of the called function. Prototype declaration is also called signature of the function. It should be declared in the global declaration section properly, so that the compiler is having the information about the called function. Now let us see here. If you see, array can also be passed as an argument to the function, and called function, for this it should be defined properly. But which type of array we have to pass as an argument? Because we have one-dimensional arrays and two-dimensional arrays. How do we pass one-dimensional arrays as argument to the functions? How do we pass two-dimensional arrays as argument to the functions? First, we will discuss how to pass one-dimensional arrays as argument. Then, we will proceed to the two-dimensional arrays. Once you have the idea of passing one-dimensional arrays as an argument to the function, in the similar way you can also pass a two-dimensional array. So we are starting our discussion with a one-dimensional array. So how to pass one-dimensional array as an argument to the called function? For this, calling function must make a call to the called function using proper actual arguments. Calling function, we know it is making call to the called function. When the calling function is making a call to the called function, calling function must pass appropriate arguments to the called function. Then only called function knows that calling function is sending array as an argument to it. For that, how this calling function should make a call to the called function. Calling function, while it is making a call to the called function, it should pass two important things as argument to the called function. What are the two important things? One is first array name. Whatever array calling function would like to pass as an argument to the called function, that array name should be mentioned as the first argument in the function call. And second argument is the number of elements in the array. How many elements are presently available in the array? Remember here, if you observe carefully, we are passing the number of elements in the array. We are not passing the size of the array. Size of the array may be 100. It may be declared to store a maximum of 100 elements, but 100 elements may not be available in the array. An array which is having a storage capacity to store 100 values, maybe at present it may be having only 15 values, and the remaining all 85 locations in the array may be empty. In that case, what we have to pass as a second argument to the called function, whether we have to pass size of the array or number of element. It is clearly mentioned here that we have to pass only number of elements that are presently available in the array. That we have to pass it as the argument. Note here carefully, calling function, when it is making a call to the called function, it should pass two arguments. These arguments are called actual arguments. What are these arguments? The first argument is the array name. Array name means whatever array the calling function would like to pass as argument to the called function, that array name should be mentioned as the first argument. Only name of the array, that is enough. And then second argument is presently how many elements are available in that array. So that is to be passed as second argument, not the size of the array. Then what is the syntax? How a calling function makes a call to the called function? The syntax is very simple. You have to write called function name, and then inside the parenthesis two arguments are there as we discussed just now. First argument is simply the name of the array which is to be passed as argument to the called function. The second argument is the number of elements that are currently available in the array. It is a only one-dimensional array. Remember that. What we are passing, the syntax is simply called function name, inside the parenthesis array name which is to be passed as an argument to the called function. Second argument is how many elements are presently available in the array. So this we have to pass as an in the function call. Calling function is making a call to the called function like this, using this syntax. Function call is terminated with a semicolon. Observe carefully here. Then you see one example. Then this is about the part of the calling function, how it is making a call to the called function for passing a one-dimensional array as argument. Now coming to the called function. Called function must be defined with suitable formal arguments in the function header. we know that user defined function definition consisting of two parts, function header and function body. Function definition is nothing but the complete implementation of the function. It is consisting of two parts, function header part and function body part. In the function header part, it should be defined with the suitable formal arguments. Means what argument we have to define in the function header. First argument is array name with one sets of brackets. First argument is nothing but array name with one set of bracket. One set of bracket indicates that this function is receiving only one dimensional array as an argument. That is the meaning of one set of brackets. Inside the brackets, we should not write any value or any variable. Only just array name followed by one set of parentheses. That is the first formal argument in the function header. And second argument is number of elements in the array. Number of elements is always an integer value. So therefore it is an integer argument. That is the two formal arguments that we have to declare as formal arguments in the function header. The syntax, if you see, the syntax for the called function header is like this. A return type of the function means if the function is expected to return any value to the calling function, that return type, it may be integer value, it may return integer value, or it may return float value, or may it return double value or long double value or character value, whatever it is expected to return, that value we have to mention it as a return type. If the function is not expected to return any value, it is mentioned using void keyword. Then followed by the return type is the function name, called function name. What is that function name that we have to write? Called function name. And as we discussed here, the first argument is array name. Array name with one set of square brackets. This is the first argument that we are mentioning here. Data type. Data type represent what type of value this array is storing. That array name, one set of brackets. This one set of brackets represent that it is receiving one dimensional array as an argument from the calling function. Second argument is a variable of integer type. So what it is representing? It is representing that the number of elements that are currently available in the array. So these two are the arguments to be mentioned in the function header. And this function header is very similar to the function declaration statement. The difference between the function declaration statement means prototype declaration or signature of the function, and the function header is only one difference. The function declaration terminates with a semicolon, but function header doesn't terminates with a semicolon. Here see, since this is the function header, we do not have any semicolon at the end. Example, see one function int means return type of the function is integer, means this function is expected to return an integer type of value to the calling function. The function name, called function name is largest function. And see, if you see, first argument is an array. The name of the array is A. The one set of brackets here represent that this array is receiving one dimensional array as an argument. And what type of value it is expected to store? It is, this array is declared to store only integer values. And second argument is number of elements that are present in the array. It is an integer value, int n. N, what n represent here? N represent that n number of values are currently available inside the array A. and array A is expected to store integer values. Array A is declared to store integer values, and then second argument is telling that this array A contains n values inside the array A. Then this is about the function header. Coming to the function declaration or function signature. The function signature is also very similar to the function header, except that it is terminating with a semicolon. That is what we wrote here. Called function must be declared with suitable formal arguments to the compiler, like the function header. What should be there in the function declaration? Same arguments. Array name with one set of square brackets representing that this function, called function, will be receiving an one-dimensional array as an argument from the calling function. Then second argument is the number of elements in the array, which is usually an integer argument. Number of elements in the array is always an integer value. The syntax for called function prototype declaration is very similar. It is very similar to the function header, except that at the end you are having a semicolon. Return type followed by the called function name, data type, array name, and then one set of square brackets, and then integer arguments. The function declaration is terminating with a semicolon. That is only the difference that we have discussed already. The difference between function header and function declaration is only semicolon. In the function declaration, we will be having semicolon at the end. And this is most important point. You have to note down it, or you have to underline it. What is that important point? In the declaration, function name, in the declaration of the function, the variable names are optional. I will tell you an example, then you will understand it easily. So function declaration is done like this. Int largest is the name of the called function, and this function is expected to return integer type of value to the calling function. And what are the arguments it is going to receive from the calling function? First argument is integer type of argument. Integer type of array. Array name is A, and it is one-dimensional array. One set of square brackets represent that it is a one-dimensional array. Array name is A, and this array name is optional in the function prototype declaration. But in the function header, you must have variable names. Here variable name is optional. Even if you do not have this array name, there is no problem. So that is mentioned here. See, first argument is int. Only one set of square brackets represent that the first argument is nothing but it is going to receive a one-dimensional array as an argument. What is the name of the array? You need not mention in the function declaration. So this is one type of model, and this is another type of model of declaration of the function. And second argument, if you see number of elements, integer argument. Here variable name is not mentioned in the model 2. See, in the model 2 you do not have this array name A, you do not have this second variable name L. So always remember that in the function prototype declaration, variable names are optional. If you want, you mention it, or otherwise there is no need to mention. But in the function definition, variable names are compulsory. Only in the declaration, they need not be mentioned. If you want to mention, you mention them. And one more thing you should also remember, that whatever variable names you use in the function declaration, same variable names need not appear in the function header. Because here whether you mention the variable names in the declaration or not, compiler doesn't consider your variable names. Even if you mention, compiler ignores that name. So therefore, in function definition, Even if you use other variable names, compiler doesn't raise any error. It doesn't tell that in the declaration you mentioned this variable names, in the definition you are using another variable names. It doesn't raise no error. Since why it is happening means in the function declaration, prototype declaration, variable names are optional. Because of that, even if you mention the names of the variables, it doesn't consider. Compiler doesn't consider variable names in the function prototype declaration. That is what this. So like that you can pass arrays as argument from the calling function to the called function. The most two important points you have to remember when you are passing array as an argument to a function is, read these two important points. When an array is passed as an argument to the function, it passes the address of the first element of the array. Hence, both calling function and called function will work with the same array elements. When you are passing an array as an argument to the function, what happens? In C language already we discussed, when we were discussing pointers, already we discussed that array name always represent a pointer. Array name acts as a pointer. Array name is a constant pointer to the first element. Array name always point out the address of the first element of the array. Array is nothing but a sequential collection of elements, sequential storage of elements. Means in the array, elements are stored one after the other in sequential locations, in consecutive locations. So if you know the address of the first element of the array, the second element is nothing but it is available in the next address location. Third element is available in the next address location. So array name is always acting as a pointer to the first element. So you are passing a array name in the function call, means you are passing a pointer to the called function. To the called function you are just giving the address of the first element. If you give the address of the first element, automatically all elements are automatically found. Why? All elements of the array are stored in the consecutive memory locations. First element and then after second element and in the next location third element, like that and so on, they are stored. So when you are passing an array as an argument to the called function, means indirectly you are passing the address of the first element to the array. So it is nothing but pass by pointer or pass by address or pass by reference. So this is the concept that we discussed in the last class. When you are passing address of the elements, both calling function and called function will work with the same values. Means if the called function modifies the values of the array elements, definitely it is reflected in the calling function array. Because both calling function and the called function, they are going to work with the same copy. So therefore, called function, if it modifies the values of any element in the array, automatically they are reflected in the calling function. Why it is happening means the arrays are passed by pointers. Arrays are passed by reference. Arrays are passed by addresses. Means it is nothing but pass by address or pass by pointer or pass by reference mechanism. So therefore calling a function and a called function will work with only one set of values. So if called function makes any changes to the value of the array elements, automatically they are getting reflected in the calling function. Finally, I would like to tell you that you have to remember this point most importantly. Arrays can only passed by addresses. Addresses means pointers, but not by values. This is the most important point. Arrays can only be passed by addresses, but not by values. That is the most important thing you have to remember. Let us see one example program. how one-dimensional arrays are passed as arguments to the functions. See here, this program uses a function, user-defined function called largest. What is the function task performed by this largest function? It will determine the largest value among the given array of elements. So this array is passed as an argument from the main function to the largest function. Largest function is going to determine the largest value available among all the elements of the array. Let us see. The function is declared in the global declaration section. It is called function declaration or prototype declaration or signature of the function. So declaration always terminated with a semicolon. What is mentioned in the declaration? Return type of the function is integer. Means this function is expected to return an integer value to the calling function. Here the calling function is the main function. Largest is the name of the user defined function. We are going to use this function which will determine the largest value among all the elements of the array. First argument is the array. Here we mentioned name. Array name as A. Array name mentioning name of the array is optional here. Second argument is int m. What second argument is representing? The number of elements that are currently available in the array. Let us come to the main program. This is declaration of the user defined function largest. Let us come to the main program now. In the main program we have declared an array with a storage capacity of maximum of 20 elements. All these 20 elements are of type integer. Then along with the array, one-dimensional array, we have also declared other integer variables. What are the other integer variables? We have declared here variable n, variable I, variable b. Variable n is used to hold the number of elements or values that are currently available in the array x. And n value can be maximum 20, not more than that. Because you have declared array x with a storage capacity of maximum 20 elements, not more than that. Then I is used as a loop control variable to keep track of the elements, array indices. And then big is another variable, so which is used to store the biggest element of the array. First, we would like to read the values into the array. We are asking the user to enter how many values are there. You may be having 5 integer values or 10 integer values. First, we are inquiring the user about how many values are there with the user now. So that value, suppose n value may be entered by the user as 5. That 5 value is read and stored in variable n. N value is 5 means it represents that user is having only 5 values with him. 5 integer values. Then we will ask the user to enter all that values in a row. User is having 5 integer values. We are asking the user to enter all 5 integer values in a row. Then we are instructing the computer to read all that elements one by one and store all that elements in the array x. So here for reading the 5 values, we are using a looping statement. For I equal to 0, I is less than n, I plus plus. Since 5 values are there, we know that array index always starts with 0. 5 elements are stored in the array. Means first element is stored at index location 0, I value equal to 0. 0 means first location. It is representing first location. I value equal to 1 means it is representing second location in the array. I value equal to 2 means it is representing third location. I value equal to 3 means it is representing fourth location in the array. I value equal to 4 means it is representing fifth location in the array. 5 elements means they are stored in the array x from index number I equal to 0 to index number I equal to 4. So when I equal to 0, it compares the condition. I value is compared against n value. N value is 5 because 5 elements are there. I value is starting with 0. 0 is less than 5. It is true. So therefore it reads first value and stores at index location x of I value is 0, x of 0 location. Then I value becomes 1, it is incremented by 1. Again it is compared with n value. 1 is less than 5, it is true. It reads, you are telling the computer through the scanf statement to read next integer value and store at x of I location. X of I means I value is now 1. So x of 1 location it stores. Then I value is incremented by 1. I value becomes 2 now. Previously it is 1. Now it becomes 2. 2 is less than 5. It is true. So it will reads next integer value stores at x of 2. X of 2 means third location. Third value is stored. Now I value is incremented. I value becomes now incremented by 1. Previously it is 2. Now it becomes 3. Again it is compared with n value. 3 is less than 5. It is true. It reads second integer value stores at x of index location I. I value is 3 now. X of 3 means fourth location. It stores. I value is incremented again by 1. Previously it is 3. Now it becomes 4. Again it is compared. 4 is less than 5. It is true. It reads last integer value and stores at address location x of I. I value is 4. Now I value is incremented by 1. Previously I value is 4. Now it becomes 5. 5 is less than 5. So condition becomes false. For loop is stopped there. So this how this for loop is working and how values are read into the array elements already we discussed when we have discussed about arrays. Now all 5 values are stored in the array X. Then we are making a call to largest function. Since largest function is returning integer value, in the prototype declaration it is mentioned that it is returning integer value. So therefore we are using largest function on the right side of the assignment operator. So that this function is getting executed and it performs some computations and returns an integer value. That integer value is stored in the big. But we know largest function we are using, it is a user defined function. The task of this largest function is to determine the largest value of the array of elements. So those elements are stored in the array. So out of all these elements it will determine the biggest element. That biggest element it returns. So that the integer value, biggest value is stored in the big. And main program is displaying whatever content is stored in the variable big. Variable big gets that value from the largest function. So here we are making a call to the largest function. Largest function is called by passing 2 arguments. What are the 2 arguments? X. X is nothing but name of the array. Array is passed as argument. N. N is nothing but number of elements in the array. Since this function is called here, temporarily main program is stopped for its execution. It is temporarily suspended for its execution. And the control is transferred from this function to the largest function. In the largest function, X values are assigned to array A. Array A. And then N value is copied into variable M. Now, how this is happening? Means array A, it is nothing but it is representing array X. Both A and X are same. Because X is nothing but it is a pointer which is pointing out the address of the first location. Array name is acting as a constant pointer to the first element in the array. So since you are passing the address of the first element, that address of the first element is assigned to variable A here. So variable A is nothing but it is also array name here. Array name. This is another pointer. So directly it is pointing out the original elements. M. M is nothing but the number of elements. N value is copied into M. Now see, inside the largest function, we have declared 2 more variables, I and max. I is used as a loop control variable and max is used to hold the maximum value of array of the elements. We are assuming that first element of the array, first element is available at the index location 0. So that element we are assuming that it is the maximum value. And then we are comparing this max value with all the values in the array elements. When I is changing from index location 1 to up to less than M. M value is nothing but N value. N value is 5. So therefore M value is also 5. So I is changing from 1 to I is less than 5. Less than 5 means I can go up to 4. So when I value equal to 1, it will compares with the second element. Maximum value is compared with the second element. Max is, if it is less than second element, I value is 1. 1 means second location. Max contain the element, first element of the array. So first element is compared with the second element. If the first element value is less than second element, then we know that the second element is the biggest element now. So therefore, we are copying that second element value. A of I value is 1. A of 1 is copied into max. Means whatever value is previously available in the max variable, that is overwritten with the latest value. Means second variable. Again, I value is incremented. I value becomes now 2. Previously it is 1, it becomes 2. Means it is pointing out third location in the array. So I is less than, I value is 2, 2 is less than 5, it is true. Again, max value is compared with the third element. If max value is less than third element, there is no problem. There is no problem. That third value is copied into max, because third max value is less than third element means third element is the biggest element. That biggest element value we are copying into max. So I value is incremented. I value previously it is 2, now it becomes 3. 3 is less than 5. Again, condition is true. It enters into the loop. Again, max value is compared with I equal to 3. I equal to 3 means A of 3. A of 3 means fourth location. Max value is compared against the fourth element in the array. If max value is less than fourth element, that element is copied. If max value is not less than fourth element, so this if loop is, if condition becomes false and nothing will be executed. I value becomes incremented by 1. Previously it is 3, now it becomes 4. Again, condition is tested. 4 is less than 5. So condition is true. Again, it is max values compared against the A of 4 means fifth element in the array. So if it is max value is less than fifth element is copied into max. If max value is not less than fifth element, max value means whatever is stored in the max, it is greater than fifth element. So therefore max contains the, finally after comparing all with all 5 elements in the array, max contains the maximum value. That maximum value we are returning to the main program. Now once this return statement is executed, control is going back to the, from the largest function it is coming back here. So largest, finally it is determining largest value that is stored in the big. Now main function, this function is largest function is terminated because all its code has been executed. Control is transferred to the main function. In the main function, execution starts from here. So largest function returns maximum value. That maximum value is stored in the big. That is the biggest value. So main function resumes its execution and prints that big value and program is terminated. So like that we can pass one-dimensional array as an argument. Similarly, we can also pass two-dimensional arrays also as argument. It is very similar. But in two-dimensional array, we have elements in row-wise and column-wise. To tell that, we use two sets of brackets. And here one more condition is, whenever you are passing two-dimensional array as an argument, the size of the second dimension must be mentioned. Size, not the number of elements that are available. Okay. So second dimension means columns. First dimension means rows. The column size must be mentioned. That is only the condition. Rest of everything is same. So firstly we will refer how these two-dimensional arrays are passed as the argument to the called function. Calling function must make a call to the called function using appropriate actual arguments. So what arguments it has to pass while making a call to the called function? First argument is array name as usual. And nothing is there along with the array name. Then second argument is number of elements in rows and columns. How many elements are present in the rows and how many elements are available in columns. Okay, so number of rows and number of columns in which elements are available. That should be passed. Means total 3 arguments. One is array name and second one is number of rows containing the elements and third argument is number of columns containing the elements. 3 arguments that we have to pass. Syntax for making a call to the called function is called function name, simply array name, rows containing the elements, number of columns containing the elements. That is simple. And coming to the called function header, how it should be defined. Called function must be defined with suitable formal arguments in the function header. How it should be defined? An array name with two sets of brackets. It should be defined. With the column size must be mentioned in the second set of brackets. Column size should be declared. Column size should be same in the function declaration and in the function definition. And the number of rows containing the elements and the number of columns containing the elements. Total 3 arguments must be mentioned. And the number of rows, number of columns, both these 2 arguments are integer type of values. If you see the syntax for function definition, it will be like this. This is the function header appearing in the function definition. Return type means whatever value it is expected to return to the calling function, that return type of the function, followed by the called function name. Then data type means of the array. Data type of the array means what type of values this array is expected to store. That the array may store integer values or float values or double values or something else. See, 2 sets of brackets. The size in the second set must be mentioned. Capital N. So capital N represents that this array contains total n number of columns. And second argument is number of rows containing the elements. In how many rows elements are there? Array may be having 20 rows, but all 20 rows are not filled with elements. Array may be having elements in only first 3 rows. So therefore, we will mention second argument as argument value as 3. 3 means the array is having only elements in 3 rows. And third argument is number of columns containing the elements. In how many columns elements are there? Array may be having 20 columns, but elements are there only in first 4 columns. So third argument is only value 4. 4 means this array is having only elements in 4 columns. 3 rows and 4 columns. Like that we will pass. See how the function declaration is done. We know the function declaration is very similar to the function header, except that function declaration terminates with a semicolon. Example, see here how this function header is mentioned. Int average, int a of first set of brackets, second set of brackets. Second argument is integer m rows, integer n number of columns. Function name is average. It is expected to return integer type of value to the calling function. First arguments to average function represent 2 sets of brackets represent that it receives a 2-dimensional array as an argument. The array name is A and this array stores only integer type of values. And how many columns are there? Total capital N number of columns are there in the array. Number of columns should always be mentioned when you are passing 2-dimensional array as an argument. Where to mention this? The dimension of the number of columns, second dimension. It should be mentioned in the function header and also in the function declaration. That we have to remember. M is the number of rows containing the elements. N is the number of columns containing the elements in the array A. Now see, called function must be declared with suitable formal arguments to the compiler, like in the function header. Already we know function header and function declaration is same. Function declaration, first argument is array name with 2 sets of brackets and with the column size should be mentioned. Definitely you have to mention number of columns in the array. Number of rows, second argument is number of rows containing elements. Third argument is number of columns containing the elements. Syntax is very simple. Return type, called function name, data type, array name, 2 sets of brackets with second dimension must be mentioned, size of the second dimension. N is the size of the second dimension, means the total number of columns that are there in this array, and number of rows, number of columns as second and third arguments respectively. So this definition terminates with a semicolon declaration. It is also called prototype declaration or function signature. The variable names are optional in the declaration. Already we have seen. We can take an example of these 2 statements. Average function. Here we have mentioned variable names A, second argument variable name is M, third variable name is N. In this we have not mentioned the variable names. Okay, variable names are removed. Means you can use this format or this format. Both are same in the function declaration. And this is same as the previously that we have discussed for one dimensional array. When an array is passed as argument to the function, it passes the address of the first element of the array. Hence, both calling and called function will work with the same array elements. Because the function name, array name, acts as a constant pointer to the first element of the array. You are passing a pointer as an argument to the called function. So therefore, called function and calling function are working with the same set of values. If called function modifies the values of the array elements, it is reflected in the array of calling function. And you have to remember this point, which is most important one. What is that point? Arrays can only be passed by addresses, but not by values. That you have to remember. So same as means if you know how to pass one-dimensional arrays, the concept is same as passing two-dimensional arrays. One more program. Here we are passing two-dimensional array as an argument to the average function. This average function receives two-dimensional array as an argument and calculate average of all the values of the elements stored in the array, and then it returns that average value to the main function. So return type, since it is average, it is a float value. So that float value is given back to the main function. So it is declared to take three arguments. First argument is the array name, two sets of square brackets, tells that it is receiving a two-dimensional array as an argument. And this value 10 represents that this array is having maximum of 10 columns. Its size is 10 columns. How many rows are there in that array need not be mentioned. And then second argument is the number of rows. Third argument is number of columns containing the elements. See, in the main program, we have declared a two-dimensional array X with 10 rows and 10 columns, maximum of 10 rows and 10 columns. And this array is declared to store only integer type of values. So in the argument also, in the function declaration also, average function is declared to receive a two-dimensional array which can store only integer values. Here also X is declared to store only integer values. And other variables we have declared integer values ij, mn. Ij are used as loop control variable. I keeps track of the number of rows, keeps track of the rows in the array, and j keeps track of rows, columns in the array. I keeps track of rows, j keeps track of columns in the array. What are m and n? M represent the number of rows in the array, n represent the maximum number of columns containing the elements. M represent rows, in how many rows elements are there. N represent the number of columns containing the elements. Now see, we will read values into the array. First we are asking the user, inquiring the user about how many rows and columns are there in the array, two-dimensional array. So number of rows of the two-dimensional array, number of columns we are storing in variable m and n respectively. When the user enters, number of rows as 3, number of columns as also 3. Means it is a 3 by 3 matrix. 3 rows, 3 columns. M value is 3, n value is 3. We are asking the user to enter all the values of the array, row by row. First row elements, 3 by 3 means 3 rows, 3 columns. So first row containing 3 elements, second row containing 3 elements, third row containing 3 elements. Row by row, all elements are entered by the user. And that we are reading using 2 loops. I equal to 0, I is less than m, j equal to 0, j is less than m. So this you know how to read elements into the matrix and how this loop is working. So column by column we are reading. First row, first column, second column element, third column element. Once first row, first column, second column, third column values are read. Then we are going to the second row. In the second row, first column, second column, third column values are read. Once second row is over, then we are going to the third row, and in the third row, first column value, second column value, third column value, we will read. Then here we are making a call to average function. Average we are passing three arguments. What are the three arguments? X. X is nothing but a two-dimensional array name. X we are passing. M, the number of rows containing the elements. N, number of columns containing the elements. Once this function call is made, this main function is temporarily suspended for its execution, and computer transfer the control from this statement from main function to the calling function, where called function is declared. The called function is here. So control is coming to the called function. Called function name is average. Whatever X array it is passing, that X array elements are pointed out by the two-dimensional array A here. And see here, dimension, the size of this X array is 10. So therefore that size is mentioned as 10. And M1, N1. M1 is the number of rows in the array A. N1 is the number of columns in the array A. M1, N1 represent how many rows and columns are containing elements. Here in the function call you are passing from the main program, you are passing M value and N value. M value is copied into M1, N value is copied into N1 variable. And see, inside average function we have declared again few more variables, I, J, and then mean, sum are declared. What we are doing, sum is equal to 0. Initially sum is assigned to 0. I and J we are using to keep track of rows and columns in the A array. We are calculating sum. Initially sum is initialized with 0 value. Here all elements are added when these loops are executed. And how these loops are working you know for arrays. Then when sum is obtained and stored in the variable sum, sum is nothing but, average is nothing but sum divided by total number of elements. How many elements are there? It contains M1 rows and 1 columns. So therefore M1 into N1 elements are there. So sum divided by M1 into N1. Since sum is declared as integer, integer variable divided by this multiplication is also integer. Integer divided by integer gives an integer quotient. But in the mean when you are finding out, or average when you are finding out, the fractional part is also important. So therefore to get fractional part, temporarily I have converted some value into float. And that float value is divisible with a integer value. So in float arithmetic is carried out. And that value is stored in mean. Mean should be declared here as float variable, but we declared as integer. So you declare this mean as float. Remove mean here and declare separately float mean, like that you define, and return that mean value. This function is declared to return float value, but mean you have declared it as integer, you are returning integer value, isn't it? This integer value is converted into float because you have mentioned in the function header that it returns float value. Automatically integer value is converted into float, but declare this mean variable here as float. You will get value accurately. So once that value is returned by the average function, that will be stored in AVG function here. And then main function resumes execution and displays that average value, and it is closed. Like that we can pass two-dimensional arrays as argument to the function. Then come to passing string as argument to the function. How string can be passed as an argument to the function? We know that a string is also treated as an array of characters. A string is nothing but sequence of characters. These sequence of characters are stored in a character array. Character array means it is a one-dimensional array. So passing a string as an argument to the function means again you want to pass a one-dimensional array as argument to the function. You already know, we have already learned how to pass one-dimensional array as argument to the function. In the same way, we will pass a string as an argument to the function, like a one-dimensional array. The only difference is here, in when you are passing one-dimensional array as an argument to the called function, there the array can store integer values or float values, double values or long double values or unsigned integer values, short integer values, anything. But here data type is fixed in string. String means only character data type. It is a sequence of character. That is only the difference. A one-dimensional array that can store a sequence of character, means character array is there as one-dimensional array, that we are passing it as a argument, means the data type is fixed. Data type is fixed as character because it is a string. Let us see fastly how the string is passed. A string is stored as an array of characters. Hence, the way one-dimensional array is passed as an argument to the function, a string can also be passed as an argument to the called function. Calling function must make a call to the called function using proper actual arguments. What are the arguments it has to pass? Only array name containing the string, that array name. Here, the number of elements need not be passed because we know every string terminates with a null. So therefore, null is used as a mark to identify the end of the string. So therefore, the number of characters, how many characters are there in that string, you need not pass. The calling function, how to make the calling function when it is making a call to the called function. So it uses the syntax to make a call to the called function. What is that syntax? Simply called function name, that array. That's it. In one-dimensional array, when you are making a call to the function, we have mentioned array name followed by second argument number of elements in the array. Here, number of characters need not be mentioned. Simply array name. So display, if I write name is an array containing a string. So whatever is stored in the name array, so that string is displayed by the displayed function. Then called function must be defined with suitable formal arguments in the function header. In the function header, it should be mentioned with array name with one set of brackets. And that array is expected to store character values. So character type array, one-dimensional array. Syntax for function header declaration is like this. Return type means if this function is expected to return any type of value, that return type of the function, and called function name, character, simply array name. This one set of brackets represent that it is receiving a one-dimensional array as an argument. That array is expected to store only sequence of characters, character data type. Example, void, display, character, sname. Sname is an array, one-dimensional array. It receives one-dimensional array as an argument from the calling function. And this one-dimensional array can store only characters. And this display function doesn't return any value back to the calling function. And the function declaration should also be done with a suitable formal argument to the compiler, like the function header. Array name with one set of square brackets, then one set of square brackets. Syntax for called function prototype declaration is return type, called function name, character, array name, one set of square brackets. The size of the array we are not mentioning for one-dimensional array. And this function declaration, terminated with a semicolon. The array name is optional in the function declaration. So, if you see an example like this you can mention, or like this you can mention. Here in the first model, array name is mentioned. In the second model, since it is optional, we have removed. You can follow either the first method of declaration or second method of prototype declaration. Both are same. So array is declared like this. Function, called function is declared. Called function name is display, and it is not returning any type of value to the calling function, and it receives only one-dimensional array which can store characters as an argument from the calling function. That is the meaning. Now you can take one example program. Before going to the program, remember, as we discussed the points in one-dimensional array, same points are mentioned here. When a character array is passed as an argument to a called function, it passes the address of the first character of the array. Hence, both calling and called functions will work with the same array of characters. If a called function modifies any character in the array, it is reflected in the character array of the calling function. Because we know, because arrays are passed by addresses, means pointers, by references. So therefore, both calling and called function works with the same array values. Character array can only be passed by the address, but not by value. That we have to remember. This is the case for all arrays. Next, one example program to see how character array is passed. Here we are using a display function which receives a one-dimensional character array as an argument, and whatever character string is stored in that array, it is displayed on the screen. And this display function doesn't return any value back to the calling function. Hence, its return type is mentioned as void. See, inside the main function, we have declared an character array name with a storage capacity of 20. So means it can store maximum of 20 characters. A string containing maximum of 20 characters it can store. Now, see, we are asking the user to enter a string. That string we are instructing the computer to read and store inside this array name. See, when you are reading a string, we do not use ampersand. Ampersand is not here before the variable name. And you are making a call to display function by passing this array name as an argument. Now control is transferred from this main function. Main function is temporarily stopped for its execution, and then control is transferred to display function. In the display function, s name is declared as an one-dimensional array which will receive that string into this array, and that array is being displayed by the function. Display function, see percentage s name. It displays whatever array it is receiving as argument, and whatever string is stored in that array, that is being displayed by s name function. Return means control is sent back to the main program. In the main program, control comes back to display function, this statement, and from there it starts executing the statements in the main function. No statements are there except a return. So main program is closed there. So we have terminated main function here. So like this, you can pass a string as an argument to the function. Let us see some one or two example programs. Here we wrote a program using an average function that receives a one-dimensional array as an argument and calculates average of all the values of the array and returns that to the main function. It is same as passing one-dimensional array as an argument. So here we have defined user-defined function called average with the two arguments. First argument tells that it receives a one-dimensional array which can store integer values as argument. It is being received from the calling function, and that array contains n number of elements. Finally, it calculates average of all the n elements stored in the array A and returns that average value to the main function. That average is a float type of value. It returns a float type of value to the main function. Inside the main function, we declared an array X with a maximum of 20 elements. All that 20 elements are of integer type, and we declared two more variables, I and n. I is keeping track of the index numbers in the array X, and n is the number of elements available in the array X. Here what we are doing is we are asking the user how many values are there. User may be having 5 values, 10 values, 15 values, like that. Maximum 20 values you can store. Suppose user is having 5 values. He enter n value as 5. That 5 values stored in n. Then you can ask the user to enter all that values in a row. You are reading all that values, n values. N value is 5. 0 to 4 I will change, and all that values are stored in the array X from the index number 0 to 4. Then you are making a call to average function by passing array X as an argument, and then number of elements in that array available. N elements are available. N value is 5. That 5 as argument. So main program is temporarily stopped, suspended for its execution here, and the control is transferred from this statement to the average function. In the average function, array A will receive that array X elements, and M gets the value of n here. N value is 5. That 5 is copied into variable m here. Now here inside this average function, we have declared integer I to keep it is used as a loop control variable, and then float sum and mean. First we will calculate the sum by adding all the elements for I equal to 0 to I up to I value 4. Index number 0 to 4, all elements are getting added, and dividing that sum with m. Since sum is declared as float value divided by m is integer value. So float divided by integer. One of the values are float values. Floating type arithmetic is carried out, and that means in this arithmetic you will also get fractional part. means float average you will get, that is stored in the variable mean, and that mean, whatever value stored in the mean, is returned by the average function to the calling function. In the calling function, that value is copied into the average function, average AVG variable, and main function will display that AVG value here. Then main program is closed. So that is how you can pass one dimensional array as argument to the called function. Here we will see another program passing two-dimensional array as an argument. Here we are declaring two-dimensional arrays to store matrices. Here we would like to use two matrices and those elements are getting added, means we are performing the addition of two matrices elements, so that you are going to get a third matrix. So these two matrices which are to be added, we call them as A matrix and B matrix. And A and B matrix are passed as arguments to the function addMats. addMats function receives matrix A, matrix B as argument along with another matrix C, empty matrix. C is empty matrix. Then addMats function will, user defined function will add the contents of A matrix, B matrix and stores the sum matrix in matrix C. Now the main program will display the elements, resultant matrix elements along with A matrix elements, B matrix element and sum matrix elements are also displayed. See here, addMats is a user defined function which is declared to receive three two-dimensional arrays as arguments, and M1, N1 are the number of rows containing elements, N1 is the number of columns containing the elements in all these matrices. You know, to add two matrices, the number of rows and columns in the first matrix should be equal to number of rows and columns in the second matrix. So if matrix rows and columns are equal, then only matrix addition is possible. Because of that reason, I have taken only M1 and N1, only one set of values. M2 and N2 I have not taken, because M1 value will be equal to M2, N1 value will be equal to N2. Then only addition is possible. Either you can use M1 N1 value or M2 N2 value. So here I have taken M1 and N1. If you go to the main program, so this addMats function, what it will do, it adds elements of A with elements of B matrix and stores the result in C matrix. And it returns nothing to the calling function. So return type is mentioned as void. Whenever a function doesn't return any value, we have to mention its return type as void. Look at the main program. In the main program, we declared three two-dimensional arrays. What are those arrays? A, B, and C. So these three two-dimensional arrays are declared to contain maximum of 10 rows and 10 columns. And apart from these matrices, we have declared few more variables, integer variables. I comma j, they are used as a loop control variables. I keeps track of rows and j keeps track of columns. M and N represent the number of rows and columns. M is number of rows, N is number of columns containing the elements in A, B, C matrices. In all three matrices, number of rows, number of columns containing the elements are same. Then only matrix addition is possible. First, we will read the values into the matrices, A and B matrices. For that, first we should know how many rows of elements are there, how many columns of elements are there. We will ask the user, how many rows and columns are there in the matrices. We are asking the user to enter that value. Then we are instructing the computer to read that two integer values. Number of rows should be stored in M, number of columns, second integer value, is stored in variable N. Then we are asking the user, enter all values of first matrix row by row. So that we are reading first matrix element stored in array A. And then we are asking the user to enter the second matrix, means B, row by row. Second matrix B elements, row by row. All that elements we are reading and storing in matrix B. Then this should not be there. We cannot enter elements into the second matrix. Just remove this code. It is not there. This is wrong. This code. Up to here you can read. This printf statement also. It is not there. Printf statement. So total this code we have to avoid. It is not there. Because the elements into the C is a sum matrix to be computed. For that we are making a call to add mats. Add mats function. Add mats we are passing array A, array B, array C as elements. If with M and N. M representing the number of rows containing the elements, N representing the number of columns containing the elements. When you make a call to add mats means matrices. This function, user defined function, will add elements of A matrix with the elements of B matrix and stores the result matrix in C. Now when you are making a call to this function, control is transferred from the main function to the add mats function, and main function is suspended for its execution for some time, and control is transferred to this add mats function. So add matrix function definition is this one. So its header is declared to receive 3 two-dimensional arrays as argument with the number of rows M1, number of columns N1 containing the elements are received. M value is copied into M1, N value is copied into N1. Now we declared inside this function 2 variables I, j as a loop control variables, and this this 2 matrices elements are added using these 2 loops. For I equal to 0, I is less than M1. For j equal to 0, j is less than up to N1. Corresponding elements are added and they are stored in the matrix C. Once this is over, it returns back to the control, it returns back to the main function. So control comes back to the main function. In the main function, it comes here. Since this statement is executed, then it displays the first elements of matrix A. Again, same 2 for loops with a printf statement. Okay, so all elements of A matrix are printed row by row. Then we will print the elements of B matrix row by row. Then we will print the elements of C matrix row by row. So matrix addition program already we discussed when we have discussed arrays. Matrix addition program, matrix subtraction program. Already we discussed matrix multiplication program. But only the thing is here we are there directly in the main program. We have read elements into A matrix, we have read elements into B matrix, and then we have added A and B matrix. Everything is done in the main function itself. But here to add 2 matrices, we are passing 3 matrices as argument to the add mats function. Add mats function adding the elements of A matrix and B matrix and storing the result in C matrix. Then control is coming back to main program. Main program is displaying the result to the user. Means only main function is performing input operation and output operation with the user. It is reading, main function is reading elements into the A matrix from the user, elements into the B matrix from the user, and giving the result back to the user. Only add function is receiving 3 two-dimensional arrays as arguments, and then it is adding first 2 matrices A and B and storing the result in the third matrix C. That is the job of add mats function. It is not doing any input and output operation with the user. It is taking input from the main function and then sending back the resultant matrix C to the main function. That's it. Main function is making use of add mats function. Add mats function is not interacting with the user. Like that, add mats function is defined. To the add mats function, you can pass any 3 arrays as argument. It adds first 2 matrices and stores the result in third matrix. That is the job of add mats. That is the advantage. Once a function is designed, that function can be used in any program to perform the same task. That is the advantage of using functions. So main program we have, after displaying the content of C matrix, the main program is also closed here. Then this is how you can pass two-dimensional arrays as argument to the functions. Based on all these programs, we discussed 5 programs in this class. One is passing one-dimensional array as argument, then two-dimensional array as an argument, and then string as an argument to the function. For every concept, we discussed one program. At the end of these 3 concepts, we discussed 2 more programs. One program on passing one-dimensional array as argument, and another program is passing two-dimensional array as an argument to the function. Now, after practicing these 5 programs, after executing the 5 programs code on the computer, then you try to write the code for these 3 programs. Think on your own and try to implement these programs on your own, so that you will be getting a lot of confidence about how to pass matrices and strings as argument to the function. Once you look at the first program about the passing one-dimensional array as argument to the even sum. So this function, even sum function, calculates the sum of even elements that are there in the array. Only sum of even elements which are there in the array. Array may contain odd elements and even elements. It calculates sum of only even elements of the array and returns that sum to the main function. Then if you look at the second and third program, second and third programs are easy. It is very similar to the matrix addition program. Here we have used a user defined function called submat. What it is doing, it will take 3 matrices as arguments from the main function and subtracts the second matrix from the first matrix and stores the result difference in the third matrix. That is the job done by the submatrix. And if you look at the third program, it is also very similar. That is, it uses a user defined function promats. It also takes 3 matrices as argument from the main program and multiplies first 2 matrices A and B and stores the product in the third matrix called C. And main program will display as usual the elements of A matrix, elements of B matrix, elements of the product matrix, means C. That is how you have to write. Since similar programs are already discussed, you just a little modification. Wherever plus symbol is there, you have to replace with minus. Wherever plus and minus are there, product matrix production is little bit thinking is required to perform the matrix multiplication. Already we discussed in the matrices, when we have discussed the matrices, how to perform matrix product, how to multiply 2 matrices, we have discussed. There we use 3 for loops. For matrix addition and subtraction, we use only 2 for loops. A of ij is equal to, C of ij is equal to, we wrote A of ij plus B of ij for addition using 2 loops. And similarly for subtraction, we wrote C of ij is equal to A of ij minus B of ij using 2 for loops we wrote. But when you come to product of 2 matrices, we have to use 3 loops, 3 for loops. So how to use 3 for loops, we have already discussed. Just go through that program. So that the same program you can write inside the promats function. Promats function stands for product of matrices. That is how you can write. And one assignment question for this class, that is how arrays are passed as arguments to the function. Explain with an example. So for this you have to write how to pass one-dimensional array as an argument with the example program, and how to pass two-dimensional array as an argument with an example program you have to discuss. And submit this assignment day after tomorrow. Because in tomorrow's class I will give 2 more assignment questions. That 2 assignment questions in tomorrow's class, and today's class 1 assignment question. Total 3 assignment questions you have to submit it on Thursday. Okay, so today is Tuesday. Tuesday class 1 question, and Wednesday class 1 question. 2 questions from Wednesday class. Total 3 questions. You have to write the answers, you have to prepare the answers, and you have to submit it by Thursday. Okay. So thank you all for your patience listening. If you have any doubts, contact me on 9848919656. Between 9:30 a.m. to 5 a.m. on all working days, I am available to you. Thank you all. Thank you.